Hello, my name is Scott Kausler, and I'm talking about my presentation, Winning DevOps with Jenkins today. I've used Jenkins in various past projects, at least 4 or 5. I'm currently a DevOps engineer at LoveEvery, and so this is kind of the story of my experience with Jenkins. If you'd like to follow along, please go to this URL, github.com/scott-kausler/winningwithjenkins, and the links to these slides are also included there. So, what's going to happen today? I'm going to go over what is DevOps, talk about build servers in general, go over Jenkins, have kind of the fun section, which is do's and don'ts of Jenkins, and last but not least, go over a demo. So first of all, what is DevOps? The fun thing about DevOps is to be a DevOps engineer, you kind of also have to be a philosopher, is everyone kind of has their own definition and ideas of what DevOps is. Generally, it's defined as sort of this set of best practices that help you deliver software better. But you know, these slides were kind of fun to put together because each company has their own sort of definition that gets around to that point. You see, Atlassian is is kind of a good summary in my opinion. It's a set of practices that work to automate and integrate the processes between software and development and IT teams so they can build, test, and release software faster and more reliably. What does that mean though? Well, in my opinion, I like to make things simple in general. It's why I think I'm a good DevOps engineer. So my definition is a bit simpler than that. It's DevOps is iteratively making software development easier. And if you even think back to how the term DevOps came to be, it's this idea of taking this, merging development practices and operational practices together in order to better deliver software. If you think about it, like the combination of those two isn't itself a revolutionary idea, it's the iterations on top of that really help deliver particular cloud software much quicker and with much higher quality. So when your software development gets easier, you have faster velocity, your developers have more pride and motivation because they're seeing their code go to production quicker, they're actively involved in the whole process and get that feedback loop. You release your features quicker, there's less developer burnout, less downtime and quicker recovery. Not necessarily intuitive, but the idea is if you incorporate deployment into your day-to-day routine, then you know everything there is to know about it and you can recover quicker. Higher quality because you need the right, qualification within your pipeline, running in an automated way, so that will just bump up the quality of your application. More visibility into what's going on overall, more secure because you can easily implement security practices throughout your development pipeline, and scalability. Again, because automation once you automate something, then you can iterate on it, make it more scalable. So, that begs the question, how do you DevOps? I can tell you from my experience of a lot of ways you don't want to DevOps. You don't want to use a UI, for example, to provision cloud infrastructure. You know, all the major cloud providers have great UIs, and at the click of the button, you can run compute resources. Well, what happens though is someone forgets about what they did through the UI, or they leave the company, and you have these orphan resources there just hanging out wasting money. You don't want to give every developer admin access for security reasons. You don't want to disable your failing unit tests. They were written for a reason. You don't want to write 10 microservices in 10 different languages. This is one of the fun ones because this idea of microservices is kind of thought of as a revolution. And one of the big benefits everyone touted is, oh, we can write it in any language, it doesn't matter. Well, it does matter because you have to support then microservices in different languages. So, in my opinion, it's best to be consistent when you can. Obviously, if you need to write a microservice in a new language, you can definitely do that. You can definitely write the tools to do that, but don't start out that way. You don't want to deploy each microservice in a different way. You want to have this kind of standardized way of doing things. Standardization is, quite frankly, key. You don't want to have microservice owners. Hey, you want to standardize so that everyone on the team knows how to work on a particular microservice. You don't want manual tests because that means someone actually has to, I guess, block promotions to production. You don't want to run your unit tests from the dev box. You don't want to deploy from a dev box. You don't want to check credentials in the code. That one should be obvious. You don't want long-lived feature branches. You want to generally base your changes off master and use feature flags. And last but not least, you don't want, in my opinion, you don't want to do hot fixes. So the problem with hot fixes is they encourage you to have a second pipeline to deploy your code, when in reality you could be working on optimizing a single pipeline. To look at it another way, if you can get your code from pretty much development to production in an hour, why do you need a hotfix process? Just go through your normal process. With that, there's plenty of books if you want to learn more about DevOps. I've read a few of these, but have had all these recommended to me at some point or another. A few more tips on DevOps. Make sure you architect. This is code. You want an actual architect thinking about what you're doing. Architect your deployment, architect your test. Make sure you have common code libraries so that you can reuse code. You want to break down barriers. Don't think of it as developers test DevOps. Teach developers how to run tests. Teach developers and testers how to deploy your microservice. And standardize. I might have hit on this a little bit. Make sure you standardize as much as possible. Don't repeat yourself is a common phrase. You don't want to write the same line of code multiple times. Use data to inform your decisions. As you iteratively build up your DevOps infrastructure, you're going to get more data into this pipeline, more feedback, and that can definitely drive your decisions as to what to work on next. And optimize, optimize, optimize. Think of it this way. If you can trim 10 minutes off your deployment pipeline, how much developer productivity would you get from that? Next is, what is a build server? So yeah, transitioning off this general topic of DevOps, build server is pretty central to the practice. And the generic concept is it's just a server that runs some sort of job or executes a script. There's dozens of these technologies that do this. They give you the main benefit is the centralized, reliable environment to deploy stuff on. You don't have this problem where this developer has one environment set up on their dev box their special way, and another developer has a second developer environment set up their own way. Now your build server becomes your source of truth for how to deploy your code. It can, usually is, backed by Git, practice kind of called GitOps. It generally features triggers such as cron or Git. When you make a change to Git, your jobs trigger. And they're also called continuous integration servers. There's like 4 or 5 names for them. I like to use the term build server because it really, the idea has been around longer than continuous integration. Why use a build server? So the best article I found was this one on Atlassian. They define these 3 concepts of continuous integration. The idea, and really the idea is to drive first continuous integration, then delivery, then continuous deployment. And the idea is once you get there, you're kind of have this optimized DevOps pipeline, and you should have a very, very efficient, productive development team. So continuous integration, you try to merge to your main branch often. You run your automated tests on the build server. And the idea here is it's just kind of your build server is a gate to deploying to your main branch. Continuous delivery is a step beyond that, where instead of just running tests and building your artifacts, now your whole deployment is doable at a push of a button. This is kind of the next step, and this is often as far as companies get or development teams get, and that's fine because there are definitely a lot of business constraints that may prevent you from going to the next step. But yeah, it's a big, big milestone to be able to click a button and deploy your code to prod. The idea here is you want to eventually get to the point where you can do daily or hourly deployments. That means your changes are done in small batches, and that means that deploying to production is not really that big of a deal. It's something you practice a lot, and as a result, you don't have these big bangs, dramatic changes. You have these small changes that usually kind of go unnoticed. As far as the next step, it's continuous deployment, and this is the one where the human is not involved any way other than writing code and code reviews. Once the code review gets approved, then the code just ships to production. So how do you choose a build server? Yeah, this is a hard one. There's no guide out there online to say, oh, if you're this type of organization, use this. Generally, the guides out there are a little biased because they're published by someone who's trying to sell you a SaaS solution. This one is kind of the most unbiased one I've found from this source called Catalan. I think they do some sort of like testing, which is why they don't really care which build servers you run your tests on. And you see it's a pretty good list of comparisons. Open source is generally a big factor with any technology you choose. Ease of setup, the built-in features. When looking at this and comparing Jenkins with all the other ones, this comparison seems pretty accurate. Generally the pattern with Jenkins is to get going, it's a little harder, but that integration has 5 stars, whereas the other build servers don't. And the reason is because you can do a lot with Jenkins. You can customize it any way you want, for better or for worse. And of course, pricing is a pretty big deal. So definitely pay attention to that one. Some extra factors in addition to choosing build servers. So if you are starting from scratch, have no idea, I would definitely consider these. So first of all, how your job's defined. So it's pretty popular right now for build servers to have you define their jobs in YAML. There's also some that just are UI based, and some that use programming languages like Jenkins is based off of Groovy to define your jobs. The difference is with YAML, YAML's not a full-fledged programming language, so just kind of consider that. Whereas Groovy is, has its pros and cons. You can do a lot more, but with great power comes great responsibility. You can definitely find yourself messing with your build server. What is the build agent topology? So there's SaaS managed solutions. There's the build agent is what's actually running the job. So generally you want to have, I guess, multiple agents actually running the code for your job, or if you're building an artifact, for example, you want to do that on a remote agent. Jenkins is dynamic, or Jenkins can do whatever you want to do, but an example of a dynamic build agent is one that spins up as you run jobs or as it's needed. So that's what I like, because that means you don't always have an agent running, so you can spin it up as needed. There's also native or on-prem options. So just again, depending on the needs of your group, you may want to run your build agents on-prem. As far as the next factor, your coordinator topology. So the coordinator is who kind of orchestrates those agents, who sends jobs to those agents. Jenkins or Bamboo would use a single coordinator topology. The SaaS managed solutions, obviously, they don't expose that. It's just kind of a dashboard you use. And there are some that have more of a distributed model, meaning there's not like a single compute instance running your controller. Spinnaker is one example of that. Spinnaker is not necessarily a build server. They advertise themselves as more continuous deployment server. I'm not going to get into the differences, but there are some that support this. What is the library support like? Again, YAML versus Groovy. It's about, I guess, flexibility versus, I guess, danger. And as I mentioned, cost is a huge factor. Before I get to that, with those factors, just going over kind of this introduction of what particularly is Jenkins. So Jenkins is a build server. It uses a controller agent architecture, meaning single controller that manages the jobs. The controller also runs any plugins you might install in Jenkins. It controls the UI, and then it has zero or more agents that can run the scripts you provide in the jobs. It can be installed natively in Docker or as part of the AJRE. Supports Windows, Mac, Linux, and very, very customizable. Again, this is, I guess, the big thing with using Jenkins is tons and tons of plugins. My phrase is going to be, if you're not using plugins with Jenkins, you're not using Jenkins correctly. The Jenkins 2.0 kind of is automatically released with the concept of pipelines, and it's Jenkins kind of attempt of doing continuous integration, continuous deployment. So yes, you should be using pipelines with Jenkins. It's pretty much a collection of plugins that enable continuous deployment, and again, it has Groovy syntax. So now that that's out of the way, I want to do a deep dive on cost between Jenkins and CircleCi. CircleCi is one of the cheaper SaaS managed build servers out there, so if you're thinking about going that direction, this should be a pretty useful practice for you. So, in this comparison, we'll have Jenkins with a single controller using 2 CPU and 4 gigs of memory, deployed on an AWS T4G medium instance that costs $24.50 a month. Plus, to do Jenkins effectively, you'll need at least one agent. In this scenario, let's say this agent's continuously running, so it's not dynamic, just always out there running. That's going to be another $24.50 a month for a total compute cost of $49 a month. On the other hand, based on CircleCi's pricing page, the same kind of instance class is going to run you $256 a month because they charge you based off of kind of a much higher fee based off run time. But the thing with Jenkins is, as everyone claims, is Jenkins costs you a lot more in development cost. My argument is I wouldn't say a lot more, but I am going to acknowledge that there is more development costs with Jenkins. So let's factor that in. So say you have one skilled DevOps engineer that costs your company $150,000 a year, and that DevOps engineer spends 5% of the time on Jenkins server maintenance. That comes out to $625 a month. Added costs that you theoretically do not have with CircleCi. So if we do kind of the comparison with the last slide, we'll find if we have 2.8 agents running continuously, that's going to be the break-even point for Jenkins and CircleCi in this scenario. So the reason nobody actually does cost comparison like that is there's a lot of caveats that comes with it. Obviously, this is very, very contrived. Build server jobs, for example, tend to be batched rather than continuous. Doesn't include procurement cost. You may, generally you can't just take your credit card and buy CircleCi online with it. You got to manage a relationship with your vendors. Each CI tool has its own cost structure, so again, if you're choosing a different one, you'll have to do this practice with that tool. CircleCi does allow for self-hosted agents, so think of it this way: is you can make similar topology with CircleCi, and the cost would be different, or the cost structure would be different. They also probably have better prices than what's advertised. But on the other hand, Jenkins compute costs could be less with spot instances in AWS, for example. And the big one here you got to remember is this does not account at all for productivity gains from each tool. If you're using Jenkins religiously, it is very likely that server maintenance cost is going to be very trivial compared to the productivity you gain from using the tool. And it doesn't account for time spent researching or writing job definitions for each tool. That's something that's pretty hard to measure. Like, I don't know if it takes less time to write a CircleCi job or a Jenkins job. It's just kind of a lot of factors that go into that. So, with that, we're going to get into my recommendation on how would you use Jenkins, or why would you use Jenkins. How is later. You got to ask yourself your same questions of each technology you use. So, why would I use Go for my server language? Generally, the language is built to make developers more productive, and it's got greatest performance. Why would I use Kubernetes for my Docker orchestration? It's got this infrastructure code model with YAML. It's very, very extensible, and just the features you get with it. And likewise, why would I use Terraform to provision my cloud infrastructure? It's got declarative syntax, extensible and powerful configuration language. The point of these questions is that the technology you use matters. And that's the same answer in each of those cases. Why would I use Terraform? The technology you use matters. I'm not saying that you have to use Terraform. I'm saying think about it. So to answer the question more directly is, why should you use Jenkins? Again, flexibility. It's not tied to an opinionated build server. You can do whatever you want with Jenkins. And likewise, you can support the architecture to meet the needs of your organization. For example, some organizations may not allow your code to leave some sort of intranet. Well, you can't use a cloud-managed build server if that's the case. The agents support all major operating systems, and I mentioned the Groovy-based definition language. It's extensible. Remember, if you're not using plugins with Jenkins, you're not using Jenkins correctly. It's open source. You can contribute. You can view code if you're having a particular tricky problem with Jenkins, and you don't have vendor lock-in. It's battle hardened, been around since 2005. Somebody's solved the problem you're experiencing in Jenkins somewhere. So, and it, likewise, it's pretty stable since it's been around for so long. Costs, licenses, and as I mentioned, your agents can be dynamic for extra cost savings. Security, again, with the flexibility, you can implement whatever security practices you want around Jenkins. So you can deploy within your own VPC. You can, for example, use roles rather than credentials. If, for example, you're deployed in AWS, you can make your compute instances assume a role rather than giving it a username password to access AWS resources. There's special plugins to manage security. And as you'll actually see in the demo, you can get notifications on security vulnerabilities. Why wouldn't you choose Jenkins? So again, there's very legitimate reasons why you wouldn't want to use Jenkins. Mention the setup and maintenance cost. There's reliability and scalability. And they actually even have documentation about how to manage scalability with Jenkins. Big problem is it's a single controller architecture, meaning single point of failure. So again, if you have a lot of jobs that are going to exhaust the resources on that controller, you got to rethink your architecture. For example, upgrading will cancel all of your current jobs. So you got to be careful about when you upgrade. With that said, there are cold backup options available, so you could effectively do a replace, but regardless, it's going to cancel all your current jobs. Plugin hell is a term associated with Jenkins. This is just a dependency management problem. You're going to get this problem with any programming language you use. Make sure you don't have a process in place to guard yourself against having conflicting dependencies. But the last and least and worst reason I'd say of not choosing Jenkins is other build server technologies have better marketing. This one is my favorite because Bamboo versus Jenkins. This picture will make you think that Bamboo is great, like it does all these things that Jenkins doesn't do. When in reality, built-in Git branching workflows, this is a lie because Jenkins has Jenkins pipelines and Jenkins 2.0 with Git, and you can install plugins. Built-in deployment projects, I don't know what that means. Built-in Jira software integration, sure, but again, there is a Jira plugin for Jenkins. Bitbucket, yes, there's a Bitbucket plugin for Jenkins. Test automation and easy upgrade permissions, again, you can find plugins to give you all these features. So be careful what the marketers say. So with that, what's my recommendation on when to use Jenkins? So if you have a small team, let's say less than 5 devs, it may not be worth investing in Jenkins. On the other hand, if you have at least one dedicated DevOps engineer, that's probably the time to start really thinking about your DevOps architecture and your build server. So yeah, start using Jenkins. Is your pipeline already using another build server you like? Great, stick with it. Is your DevOps engineer a wizard with another build server? Then use it. Are you using Kubernetes? Awesome. You should deploy Jenkins on it because both open source technologies, they tend to go hand in hand, and there are people who actively work on deploying Jenkins on Kubernetes. Do you have no build server at all? Well, then that should be your #1 priority to implement a build server. So now we get to how do I use Jenkins? And this is my favorite because it's the do's and don'ts section here. A lot of these are practices I've experienced myself in various, again, Jenkins installations I've used. So, first one, don't create or modify jobs from the Jenkins UI. Again, this goes back to don't create resources in your cloud provider's UI. It's hard to standardize your job definitions. You lose that disaster recovery, and there's a question of ownership of jobs. If somebody leaves the company, then you don't have that knowledge of how the job was configured. If you have to, or if you feel you must use the UI, there are actually some plugins you should install. The job configuration history plugin, so it keeps a history of your changes, and Blue Ocean is just kind of a pretty full-featured plugin for managing jobs through the UI. Do use job DSL to create jobs. So again, job DSL is, the idea is it's how you define jobs. So it typically has the triggers, your repos that the job is held in, maybe parameters. And so this is how you would essentially run a seed job, and job DSL would create all the kind of ways to define your job. I'm toting around this because we'll get into pipelines. Don't use free style jobs. If you've never heard of it, then don't even think twice about it. Do use pipelines. So again, part of Jenkins 2 is Jenkins CI/CD kind of implementation. And so think of it this way: is job DSL will define the job name and like where your pipeline is located. Pipeline defines everything else about the job, such as your bash script or the scripts you run within it, and the various steps. It's technically a suite of plugins that support implementing and interacting continuous delivery pipelines into Jenkins. Yeah, it's essentially just a self-contained job definition using a file type called a Jenkins file. With that, do test your pipelines as well. So there's this one plugin called Multibranch Pipeline I really like. What it will do is if you have a change to your pipeline file, then it on a particular branch, then it will run the pipeline on that branch. So say you have a master, you make a change you want to merge into master, then the multi-branch pipeline will actually pick up and run that change to pretty much qualify it before you can merge it into master. It effectively creates a job per branch, and yeah, you can also, if you're not using the multi-branch pipeline, specify the branch as a parameter in Jenkins. So again, think about your merge strategy when you're changing jobs, or when you're developing jobs, is make sure you run it on a branch to qualify it before merging it into master. You'll see the demo for the example. Don't copy paste your code. That should be obvious. Do use a shared library. So again, in general, I would suggest using a shared library for any technology you're using. Again, because now with a shared library, for example, you can define your shared library in one repo, have, say, 2 microservice repos with your Jenkins pipelines defined in. Any common code between those 2 pipelines are going to be in the shared library, and the pipelines themselves then can be customized based on each individual repo while using the library where appropriate. But yeah, that's a pretty common model within any language you use. Do define your agent configuration in your library. So again, with dynamic agents, for example, you can, in Kubernetes, you can specify your agent having, it's effectively a Kubernetes pod with different Docker containers running the tools you need. If you have it all in your library, that means that if you need to make, say, a version change to one particular tool, you don't need to make changes across every microservice. You have one PR in your library. Do write unit tests. So Jenkins has a few unit test libraries. So Jenkins uses Groovy, but it's kind of its own special language based off of Groovy. So these unit test frameworks try to kind of, I guess, test the differences. Generally, so your Jenkins Groovy files will compile with Groovy, but hopefully these catch a lot of your kind of weird Jenkins syntax errors as well. It doesn't, however, work for like shell scripts, so you gotta, if your whole Jenkins pipeline is one big bash script, for example, which can happen, you don't get the benefits of these unit tests. That's why you shouldn't rely on just unit tests. So, I already mentioned test your pipelines. So the thing is, like, Jenkins is the only thing that can truly understand and run your pipeline file. So run it in the Jenkins instance itself. Yeah, and yeah, I mean, think of this library as your integration test of the library. So again, don't ever merge a Jenkins job change without running it once. Likewise, you want to treat Jenkins like a microservice. So again, don't think of it as just like this one build server out here. Think of this as this, it's got as much configuration as any microservice would. So again, make Jenkins and continuous integration a core competency in your organization. Create a deployment qualification pipeline, as I've mentioned. Put all the code in source control, do code reviews, make sure you have proper security around Jenkins. If this is a big one, if Jenkins breaks, remember you cannot then deploy any code to production. So other than an actual production outage, Jenkins should be kind of your highest priority thing to maintain. Don't put credentials in plain text. Obvious one. Do use Jenkins for credential management. They have a plugin for that. Don't give everyone admin access. Do use matrix authorization. So another plugin where you can specify access based off of, or fine-grained permissions based off of users and groups. Do integrate Jenkins with your authentication provider. Again, they have plugins for most of them. So in the demo, for example, I'm going to use GitHub authentication. Do use dynamic agents. Touched on this one. It's should reduce costs because you don't have something always running. Do update Jenkins and your plugins regularly. Again, Jenkins will notify you if there's a plugin update available. Avoid multiple types of agents. So this is a tricky one. So at least initially avoid multiple types of agents, because what happens is you're going to have, you can either have like one massive kind of build agent configuration for all jobs, and that's a well-known configuration. It ultimately reduces your maintenance qualification burden. There are some instances where you have to have multiple agencies, like if you need an agent for Windows, Linux, and Mac. And multiple agents do have benefits. The big one is your smaller Docker images. But again, if you have like just one agent, you're going to download it once on your machine. That image size shouldn't be a major factor. Quicker load time. The image is tailored to the job type. So again, if you have a Go job type, or if you have a Java job type, you could have agents optimized for those. And one example of a case where you might want to have multiple types of agents would be using Kaneko for Docker builds, just because of how specialized that agent is. So that's why this is a void rather than a do or don't. Don't manually configure Jenkins. Yeah, you want to check it into Git, use GitOps for better traceability, reproducibility, be able to roll back any changes, and disaster recover. If everything goes down with Jenkins, then you can easily spin it back up. If you use this configuration as code plugin, which you'll see more of in the demo. Don't leave your main branch unguarded. So this is another concept that it's actually one of those things, like if you learn nothing else from this presentation, learn this, is that you don't want to let anyone just push directly to your main branch. This leads to pretty much broken code. Everyone uses your main branch. Everyone rebases from your main branch often. So once you push a break and change to your main branch, you kind of disrupt everyone's processes. So what do you do instead? You want to architect your Jenkins jobs in a way that protects main. So the way you do this is you create a job whose sole purpose is to validate code, then merge your pull request to the main branch. In this way, you can run any number of tests. You can deploy your code to the cloud even if you want, and run end-to-end tests if you want to. And this effectively allows you to put any checks you want before merging into your main branch. And it's this guard to make sure that at any moment in time, your code is always deployable. Not everyone does this. A lot of kind of build server models kind of encourage building after you push to a branch, but by that time it's kind of too late. At that time, someone has to fix your main branch. I linked here this article by GitLab, so they actually do also support a way to architect your jobs to support your main branch with merge trains. The funny thing about GitLab is you have to pay more for this ability. Do use the Kubernetes operator or Helm, so this is how you would deploy Jenkins to Kubernetes. Both are viable options. My demo, I'm using the Kubernetes operator. It allows you to pretty much take the default Jenkins image, and it would add necessary plugins and configurations on top of that. The Helm chart, you should bake your plugins into your image. So in that regard, the Kubernetes operator is more flexible, but I would say the Helm chart is more stable because, again, you have that version released image to use with Helm. But yeah, the operator uses the Kubernetes operator pattern, which is becoming more and more popular with a lot of Kubernetes tools. You can research more about it. With that said, you have the flexibility to run Jenkins anywhere, not just in Kubernetes. If you have a Kubernetes cluster, though, just put Jenkins in it. Touched on this last slide a little bit. Do make an image of your controller and the agents. So, for example, Docker or VM image. You want to install all the plugins in your controller ahead of time, and by doing this and then qualifying that controller image, you pretty much solve the plugin hell problem I mentioned earlier, and you avoid dependency mismatch. And then by requiring all this required software in the agent, this is another thing that's really weird. I see a lot of examples with this, but you don't want part of your job to be installing the software required for the job. So, for example, you don't want to install Node as part of your job. Why don't you just run your job on an image that has Node already installed? The idea is you do have a larger a larger agent image, but you have quicker build times, more optimized build times, because you don't have that extra step. And the ultimate result is more developer productivity. Maybe backup Jenkins. I like the idea of writing your Jenkins jobs such that they don't require a backup. If your Jenkins infrastructure all went down, you just have to recreate it, and all the jobs run and your pipeline runs as normal. but that's not always how we can write our jobs. If you do use a UI to create a job, I would say it's required to back up Jenkins. You have several options. Jenkins itself doesn't kind of have a recommended backup. You can use your cloud provider's backup functionality, such as AWS has EBS snapshots, or you could write a script. A lot of Jenkins job configuration, all it is just a bunch of files in a directory system. So if you can copy that directory system somewhere, you've backed up Jenkins. Do read the documentation. So 3 very useful places you can read about Jenkins is its user documentation, CloudBees, and of course Stack Overflow. CloudBees is, I haven't introduced it yet, but it's kind of the SaaS offering that offers Jenkins. So they actually will manage your Jenkins for you at a cost. But they do have a lot of good documentation, a few open source plugins that are great, and yeah, very, very, if you want to go with the option of using them to manage Jenkins, that's one option. Okay, so next we're going to go over my demo. A few things about it. So it's deployed in Kubernetes. Again, as I touched on several times already, is kind of an easy approach to deploy Jenkins, and yeah, there's tools that allow you to do it, such as the Kubernetes operator, which I'm using. And the other tool I'm using to deploy is the Terraform Kubernetes Alpha provider. So using Terraform because of its, well, all the benefits it offers, like drift detection, saving state, declarative, rich configuration. But this Kubernetes Alpha provider is pretty new, but it's the first time you can actually use a Kubernetes custom resource definition in Terraform. So again, now you get the benefits of Kubernetes plus the benefits of Terraform. And it allows you, I'm using workspaces to show you multiple instances of Jenkins, as you'll see. So again, if you want to look at the demo, go to github.com/Scott/winning with Jenkins, and also there's a link to these slides. So if I jump over to the demo, so what I did already is I do have the prod Jenkins instance deployed using this command, but while I talk, I'm also going to deploy a non-prod version of Jenkins. And I can deploy any number of these as I want. So let's say I want to deploy the workspace name as Idaho Tech Council. I hope I spelled that right, and I hope trying out this name doesn't cause me any issues. It's just doing a bunch of Terraform-y stuff right now, but creating all the Kubernetes resources required for Jenkins. If we hop over the code, what you'll see is the README has kind of the steps you can use. If you want to deploy your own Jenkins instance, pretty easy. All you need to do is deploy or install Docker Desktop with Terraform, enable Kubernetes, fork this repo. You don't have to, but I would suggest forking it for kind of the to try out the GitHub authentication features. You fill in the fields from env.example, so that's where I keep my secrets I'm using, and you'll see where I use those in a minute. And just browse to the URL output and play around. So the prod, for example, the prod environment I have, if we look at this env.example, I'm setting up some Kubernetes stuff, so this is just telling Terraform how to connect to Kubernetes. GitHub variables, so it points to where GitHub's at. And then if we want GitHub OAuth to work, then you also need these variables in a workspace specific environment folder, so that's why that prod the prod release is important. But again, as you'll see, that's not required. So let's dive deeper into some of the code. So first I'm going to go to the repo and show you kind of what this Jenkins instance will do. If I have a pull request in, say, a repo, And I go to that pull request. I have these two GitHub checks. The first one is that multi-branch Jenkins pipeline that ran the job. It says, hey, this commit looks good. You can merge it. So this is kind of you can think of it as like a check commit is, if I submit a PR, I want to make sure my code is good before it merges. So it's kind of the pre-merge check. Think of it too as a way where, a developer shouldn't have to run all their unit tests every time they push up a PR. Let Jenkins do it for you. The second thing is a link to the merge job. So when this has been reviewed and I'm ready to merge, I'm not going to push this big green button that's very tempting. I'm going to run a Jenkins job. As I mentioned, it will perform all the checks required and actually get your merge to master. And I'll click build. So a few things is, again, this is my prod instance of Jenkins. And you see this is deployed on localhost using Docker desktop. If I try to go here in an incognito window, I am not authenticated. I'm going to skip that for now because I don't have a second GitHub account. But it shows you the GitHub sign-in, I should say. So from there, we have these seed jobs. This is why I mentioned these are your job DSL jobs. The two seed jobs are from the all workspace jobs, and then a prod specific set of seed jobs. And the jobs here are a build job, which does that pre-merge check, the merge job, which is running right now because I said merge my PR, and a Jenkins test job. This Jenkins test job actually, we can go ahead and run it, but the idea here is I said, qualify Jenkins before making any changes. So if I run this Jenkins test job, that's the idea. Say I have changes to Jenkins on a branch and I want to make sure that my changes didn't break the Jenkins server. You can put whatever you want in this test job, and the idea is this could be another one of those sort of gates. So again, this is my prod instance. So I just finished deploying my development instance. And if we go there, it's similar. It's got a few differences that are defined by those .env files. For example, I'm unauthenticated here and still allowed to access. So I added authentication to the prod instance, but not this development instance. And as far as the jobs, it only has that Jenkins test job. So this is a way you can say, don't put jobs that are truly meant for my production instance on my development instances of Jenkins. So yeah, we check back in with that merge job back on the production instance, and we can check back into GitHub, and running with Jenkins, there's no pull requests anymore. If I go to that closed pull request, Jenkins merged it for me. So that's the example there of running your unit test and merging only if they pass. So that's kind of throwing a lot at you. So let's look at again some of the code. There's that env example file. Some interesting things is a make file that again lets you specify your workspace, your command. The Terraform code, which uses the alpha provider. I don't know. There's this is the configuration as code plugin. So the idea here is you can put the plugin allows you to store your configuration in Jenkins config maps or Kubernetes config maps, and then Jenkins will load it up at boot time using the Kubernetes operator. You see here, this is where I'm configuring the GitHub credentials and using the power of Terraform, I'm profiling it out based off if the environment is prod or some other environment. The Jenkins declaration has all these plugins. So this is actually the true kind of thing that comes with the Jenkins operator, is you can define a YAML file that is a Jenkins. If you create this Jenkins YAML file, you'll get your Jenkins deployed. And so actually right now I have 2 Jenkins YAML files because I have 2 Jenkins instances. In my directory structure, I have a Jenkins folder, and you can this is completely configurable. You can structure Jenkins however you want, but I have my job subfolder, which has the prod job and the kind of global job. So this Jenkins test job, the global job is here. The prod job is in the prod folder, so that's how if I'm using a particular environment, then I can load up the jobs for that particular environment. Notice here in this test job, I'm actually have a utilities method that I'm using to kind of put, again, the common code for the job DSL stuff. So again, I'm have these common methods for creating the folder and the pipeline job. And if we look at the pipelines themselves, so this is what the build and merge job actually sharing the same pipeline. I'm using a cool trick. I'm using a Jenkins pipeline library that is using the current branch, being loaded from the current branch. I'm defining my job. It's not doing much. It's got some parallel steps though that will do a setup step in my pipeline library. So this is a common thing you might have across all your repos, is I add that Jenkins merge job trigger. So that's how the GitHub pull request had an action on it, say, hey, click me to merge the job. That's all kind of abstracted in the library. And then the second step is just this is where you would build your code or build your artifacts and deploy. Finally, if this job is ran in the merge context, then you can merge it. So with that is my presentation. I thank you for watching, and yeah, you can definitely follow me on GitHub, fork the repo, ask for collaborator access if you need anything else. Thank you.